Hello, Dr. Crow. My name is Shazab Ahmed, and in this video, we're going to be just deriving an expression for the density of a perfectly cylindrical wooden log of radius r floating in water that has a maximum distance of h above the water level. So we're going to start out with drawing a diagram. I'm going to do the best I can. So here we have our log, length L, and we have a radius of R, and it's going to be, this is the water level, so this will be H, the height above the water. So we're going to assume that the log isn't moving, which means that it has a velocity of 0 and it always stays constant, which also means that it has an acceleration of 0. So since force equals mass times acceleration, we know that the net force acting on the log is also 0. But there is a buoyant force. So it's going to be, buoyant force is just equal to the weight, which is the force due to gravity. And it'll be mass of water times force due to gravity equals mass of the log times force due to gravity. Force due to gravities just cancel out, so then we just get mass of the log is equal to, mass of the water is equal to mass of the log. And we can use the density equation to solve for the masses. So from this, we can get which is the density of the water, and the cross-section area of the water, which would be this section right here, is equal to the density of the log times area, which is pi r squared times L. And this is the area of the circle, the pi r squared. So we know that the L's can just cancel out, and we just get rho W times a cross-section area of the water is equal to rho L pi r squared. So now we're going to try and solve for this cross-sectional area right here. So we know that this is equal to the large circle minus this part up here. So in order to solve for this part, we're going to use this triangle right here. So this will give us, in order to solve this, we're going to do this shape right here, area of the triangle with the cross section. So we have something like this minus this triangle. Like that. So we're going to assume, in order to get that, we're going to need to solve for the area of the triangle. And to make it a lot easier for us, we're just going to make this a right triangle with theta right here, and this whole line would be x, which is the base of the triangle, this part. So this part would also be x. So we know that 2 pi, since we're trying to solve for both, is equal to 2 pi times pi r squared. The pi's just cancel out, the 2's also cancel out, so this just leaves us with theta r squared. So in order to solve for theta, we can do arc cosine of this triangle, which would be this area minus, over r, so adjacent over hypotenuse. And this length would right here, so this whole length is radius, and in order to get this length, we can just do r minus h. So theta r squared, in order to solve for theta, we just do r squared cosine -1, which is just r cosine, of adjacent over hypotenuse, which is r minus h over h. So now we get to solve for the area of the triangle. So we know that the formula of the area of triangle is 1/2. It's base times height divided by 2. So we have 1/2 times x times r minus h. And in order to solve for x, we can just use the Pythagorean theorem, which is a squared plus b squared equals c squared. So we know that this side is x, this side is r minus h, and this side is just r. So it's going to be x squared plus r minus h squared is equal to r squared. All right, I'm gonna clean up the board and I'll be right back. All right, we're back. So in the last part, we had x squared minus r minus h squared is equal to r squared. So we want to get x all by itself, and we're just going to do some algebra for that. So it's just x equals radical r squared minus r minus h squared, which is just equal to x equal to 2rh minus h squared. And remember, for the triangle area is 1/2 base times height. So we multiply this by 1/2. So 2rh minus h squared. And get this is the height, and this is our base, times 1/2. But remember that in the log, we had 2 triangles, so we're just going to multiply by 2 because we need it for both triangles. So this then just goes to 2rh minus h squared. This is times 2 times r minus h. So this equation is the area of the triangle. So in order to get this cross-sectional area, we do r squared cosine -1 r minus h over r minus the area of the triangle. It's right here. This is a triangle. So we do area of circle minus area of triangle, r squared cosine theta, and minus, we do parentheses, 2rh minus h squared and r minus h. And we subtract all this from pi r squared. So this gives us the cross-sectional area below the water level. So now we can use that density equation we had earlier to find the density of the log. So the density of water is 1,000 kilograms. So it'll just be 1,000 times pi r squared, which is all this equation, minus r squared cosine -1 r minus h over r minus 2rh minus h squared times r minus h, all over pi r squared. So this will be our final density formula this will be our final formula that gives us the density of the log. Thank you for watching.